Hello, my name is David Evenhouse, and joining me is Nick Stites, and we are both graduate students in the Purdue University School of Engineering Education. Our presentation will be on analyzing an abbreviated dynamics concept inventory and its role as an instrument for assessing emergent learning pedagogies. This presentation was originally given during the ASEE 2016 conference and is set in the context of the freeform learning environment. First, I'll start off with an explanation of what the freeform learning environment is, as well as why there was a need to develop an abbreviated dynamics concept inventory. Then I'll turn the presentation over to Nick so that he can talk about the development of the abbreviated dynamics concept inventory, as well as how it has been applied thus far. Freeform was developed in Purdue University's School of Mechanical Engineering to enhance student learning of conceptual knowledge and problem-solving skills in dynamics. The environment takes inspiration from literature on active learning, on blended learning, which is the combination of both in-class and online resources, as well as collaborative learning, which focuses on peer-to-peer collaboration. It employs a variety of resources to help facilitate this, from a lecture book that allows students to take notes directly on the pages, to an online blog space that not only acts as an information hub for the course, but also facilitates collaboration through threaded online forums. Now, all of this is great, but it doesn't really tell you why we, or you as listeners, should be interested in this freeform environment. Since freeform was first applied back in 2009, dynamics at Purdue has seen a drastic reduction in how many students are receiving Ds, Fs, or wind up withdrawing from the course. It's also received great reviews from both students and faculty alike, so the freeform research team is interested in figuring out first how profound these effects are, and then how these effects can be achieved elsewhere, either in other courses at Purdue or in other institutions. We do this by studying the effects that freeform has on its various stakeholders, and part of what we're doing here is presenting one way in which we're measuring the effects of freeform upon student performance. Now, luckily for us, there already existed a statistically validated and reliable instrument for measuring student conceptual knowledge in dynamics. The Dynamics Concept Inventory, or DCI, was presented by Gray et al. Back in 2005 as a validated assessment tool to support curriculum development and research efforts in dynamics. Its performance was further studied by Jorian et al., who determined that it was an appropriate tool for use in class-level aggregated analysis, and identified some areas where the test could be improved as well. In this way, the DCI seemed like a natural choice for us to be employing in our research. However, in applying this, we ran into some further problems as well. Because of its length, simply taking the DCI and using it as a pre- and post-test in dynamics would wind up taking up 2 full class periods, something that the instructors in Purdue Dynamics did not necessarily want to do. So the proposal was to abbreviate the DCI and as well as append it to the final exam, which already had a conceptual component to it, and thus limit the impact that we would have on instructors in dynamics. To do this, 2 experts who were instructors in Purdue Dynamics as well as members of the freeform research team selected 11 questions that would align with the content that is taught in Purdue Dynamics. Originally 12 questions were chosen, and this was reduced to 11 and aligned with the 11 factors that were originally proposed by Gray et al. When they presented the DCI. Now I'm going to turn things over to Nick Stites so that he can talk a bit about the DCI as a tool and how we've been applying it here in the freeform research project.
Great, thank you, David. As you mentioned, we need to assess the validity and the reliability of the ADCI before using it in research or for instructional design. Now, before jumping into the statistical processes associated with these terms, I want to make sure that we all have a conceptual understanding of how we are using these terms in the presentation. So validity refers to how well the ADCI actually measures conceptual understanding of dynamics. In other words, if a student scores well on the ADCI, does it mean that they have a good conceptual understanding of dynamics? Validity helps us determine this. Reliability has multiple meanings in different contexts. And for this work, we're considering reliability as a measure of how well the ADCI questions work together to measure the conceptual understanding. The data that we used in this validation and reliability study were collected during the spring 2015 semester at Purdue University from their sophomore level dynamics class. There were 3 sections of the class, each with a different instructor, but all the sections had common homework assignments and exams. So in total, 361 students completed the pre and the post tests for the ADCI, and most of those students were mechanical engineering majors. The validity of the ADCI was explored in 2 ways. First, as David mentioned, 2 professors who are experts in dynamics selected the questions from the full DCI, and they selected those questions so that they aligned with the content covered in Purdue's dynamics course. Second, we correlated the ADCI post-test with the 4 exams in the course. There were 3 midterms and a final exam. So I want to briefly call attention to the correlation between the ADCI and the final exam score. Before we could conduct the correlation between the ADCI and the final exam, we had to extract the ADCI scores from the overall final exam scores to prevent a part-whole interaction, because like David mentioned before, the ADCI was actually embedded in the final exam. Also, the other thing with the final exam is that it mainly focused on vibrations, which is not a topic on the ADCI. So this is likely the reason that the final exam correlation coefficient for the final exam is the lowest of all 4 correlations. Nonetheless, in all cases, we found that the correlations between the ADCI scores and the exams to be significant, and the magnitude of those correlations were similar to those reported for the statics concept inventory, which gave us confidence that the ADCI was in fact assessing students' conceptual understanding of dynamics. So after reviewing the validity of the ADCI, we wanted to investigate how well the individual questions work together to assess a student's conceptual understanding. For this, we utilized Cronbach's alpha. The maximum value of alpha is 1, and the higher the alpha, the better the questions are functioning as a whole to assess conceptual understanding. The Cronbach alpha for the post-test was 0.607, which is a little bit lower than the published values of alpha for the DCI, which we found to be in the range of 0.64 to 0.84. But it's important to recognize that the Cronbach's alpha is actually directly dependent on the number of questions on the test. So this relatively low alpha that we have for the ADCI may just be reflecting the fact that the ADCI only has 11 questions compared to the DCI's 29 questions. We also want to remind listeners that the ADCI replaced a portion of the final exam that already used conceptual questions. However, the conceptual questions on the final prior to implementing the ADCI were rewritten every semester. While it's impossible to prove this, we highly suspect that the alpha that we found for the ADCI would be higher than the alpha of the final exam questions that were rewritten every semester. Therefore, we think that the ADCI is actually beneficial to the students rather than any sort of hindrance to them. The Cronbach alpha can also be used to identify questions that don't seem to be assessing the same concept as the rest of the questions. A statistic called alpha with item deleted is utilized, and we found that question 6 may need to be modified or replaced because it seems to have a response pattern unlike those for the other questions. So in summary, we feel that the ADCI is sufficiently valid and reliable for our uses. So now we want to answer the question, how can we use the ADCI to learn about students' conceptual understanding? Two common statistics used to infer information from concept inventories are item difficulty and item discrimination. For the sake of time, I will only discuss item difficulty, but I invite listeners to read our full ASEE paper to learn more about item discrimination. So item difficulty is the proportion of students answering the item correctly. And not intuitive consequence of this definition is the fact that easier items end up having a higher difficulty because a higher proportion of students answer those questions correctly. The concept inventory literature suggests that item difficulty is optimal in the 0.2 to 0.8 range, so that questions aren't too easy and they're not too hard. However, some researchers do suggest that you can include easier items, such as those testing prerequisite knowledge, if that's of interest to you. So if we look at a plot of item discrimination and item difficulty, and again, we're going to focus on the independent axis of item difficulty, we can easily identify question 1, question 3, and question 11 as easier questions. They lie outside of that 0.2 to 0.8 suggested region. Well, question 1 and question 3 are items originally taken from the forced concept inventory and were included to test students' prerequisite knowledge. So it's of no surprise that the students found those questions easy. Regarding question 11, other researchers also found that a high proportion of students answered this question correctly, so this doesn't concern us that it's outside of that region either. Lastly, I want to draw attention to the 3 questions with the lowest item difficulty. This low difficulty implies that students struggle with the concepts assessed by these questions more than the other concepts included in the ADCI. So for instructors, this could be valuable feedback to what concepts students struggle with, or they could also be markers for areas of instruction that could be improved. The last measure that I'd like to discuss is that of conceptual gain. Because we administered the ADCI as a pre and a post test, we can analyze how students' conceptual understanding of dynamics changed over the course of the semester. We can do this visually by just looking at the pre and post plots for item discrimination versus item difficulty. Hopefully we see a shift in the difficulty values from the left to the right, indicating that more students answered the questions correctly at the end of the semester than at the beginning. If we want to quantify this shift, there are a few different measures of conceptual gain that we could use, but the most popular is likely that of the normalized gain. It's used by Hake in the FCI literature, and it takes into account the conceptual understanding of a given student at the beginning of the semester. So it takes into account their pre-scores. As a plug for our other work surrounding the freeform environment, we presented 2 other papers at the 2016 ASEE conference, and videos of those presentations should be available on the freeform website. So we encourage you to take a look at those. And finally, we'd like to acknowledge the many people that had a hand in the research we presented today. We have a large team ranging from faculty members, professional staff, graduate students, and undergraduate students researching the freeform environment, and we want to make sure that we acknowledge their efforts. This concludes our presentation on the analysis of an abbreviated dynamics concept inventory and its role as an instrument for assessing emergent learning pedagogies. David and I thank you for watching, and we invite you to contact us if you have any questions. Thank you.